In this lesson, we are going to start learning about apps and how to build applications. So for our warm-up, you're going to write this in your journal. What are apps? How do we interact with them? What kind of things do apps do? I'm going to give you about 3 minutes to answer this. So, what are apps? Apps are essentially designed to solve a problem by providing a service. For example, to solve the problem of entertainment, we have apps that provide us images, movies, TV shows, things like that. For social reasons, we have apps that are for social media and for chatting, like messages. For making purchases, we have apps that allow us the experience of a marketplace. And for finding information, we have search engines and maps and apps like that. So apps have screens or user interfaces to display and collect information to and from users. These things collect information using buttons, sliders, text boxes, etc. And this is the type of information that can be displayed, things like sounds, images, video, and text. So for our activity, we are going to be looking at some apps to explore the purpose and their function. Ideally, you would do this with a partner. So if you have a partner, great. If you don't have a partner, you are more than capable of doing this on your own. So go to code.org. There are 5 different sample apps. Depending on how much time we have, I only want you to spend about 30 minutes on this, okay? So set a timer once you start and only spend about 30 minutes on exploring these apps. But you should explore at least 3 different apps, okay? What you're going to do is you're going to make a note of which app you are exploring, okay? You're going to write in your journal, what does the app do? Who is the target audience for the app? And how does the app benefit them? And then what are some ways it might be improved? In developing apps, which are a kind of computing innovation, it's important to understand both their purpose and function. The purpose helps the developer focus on creating an app with specific goals in mind. Now let's dig in to how the user interacts with the app.
My name is Mei Li Ku, and I'm a designer and an inventor. So some of the things I've designed have been at Apple, and now I design products for kids to use so that they can have an easier time in school. My other jobs include DJing and dancing. Computers are everywhere. They're in people's pockets, they're in people's cars, people have them on their wrists, they might be in your backpack right now. But what makes a computer a computer?
What does make a computer anyway?
And how does it even work?
Hi, I'm Nat. I was one of the original designers of the Xbox. I've been working with computers since I was maybe 7 years old, and now I work on virtual reality. As humans, we've always built tools to help us solve problems. Tools like a wheelbarrow, a hammer, or a printing press, or a tractor trailer. All of these inventions helped us with manual work. Over time, people began to wonder if a machine could be designed and built to help us with the thinking work we do, like solving equations or tracking the stars in the sky. Rather than moving or manipulating physical things like dirt and stone, these machines would need to be designed to manipulate information.
As the pioneers of computer science explored how to design a thinking machine, they realized that it had to perform 4 different tasks. It would need to take input, store information, process it, and then output the results. Now, this might sound simple, but these 4 things are common to all computers. That's what makes a computer a computer.
The earliest computers were made out of wood and metal, with mechanical levers and gears. By the 20th century, though, computers started using electrical components. These early computers were really large and really slow. A computer the size of a room might take hours just to do a basic math problem.
These machines are things of gleaming, vari-colored metal and numerous flashing lights.
Computers started out as basic calculators, which was already really awesome at the time, and they were only manipulating numbers back then. But now we can use them to talk to each other, we can use them to play games, control robots, and do any crazy thing that you could probably imagine.
Modern computers look nothing like those clunky old machines, but they still do these same 4 things.
First, we're going to talk about input. This is my favorite because what input is the stuff that the world does or that you do that makes the computer do stuff. You can tell a computer what to do with the keyboard, you can tell them what to do with the mouse, the microphone, the camera, and now if you're wearing a computer on your wrist, it might listen to your heartbeat, or in your car, it might be listening to what the car is doing, and a touch screen can actually sense your finger and it takes that as input on what it's doing.
All these different inputs give a computer information which is then stored in memory. A computer's processor takes information from memory, it manipulates it or changes it using an algorithm, which is just a series of commands, and then it sends the processed information back to be stored in memory again. This continues until the processed information is ready to be output. How a computer outputs information depends on what the computer is designed to do. A computer display can show text, photos, videos, or interactive games, even virtual reality. The output of a computer may even include signals to control a robot. And when computers connect over the internet, the output from one computer becomes the input to another, and vice versa.
The computers we use today look really different from the earliest thinking machines. And who knows what the computers of tomorrow will be like. My hope is that you get to help decide what you want the computers of tomorrow to look like. But across all computers, regardless of the different types of technology they use, they're always doing the same 4 things. They take in information, they store it as data, they process it, and then they output the results.
The video explained input, storage, processing, and output. In this lesson, we are going to focus on input and output. An app on a phone gets input in many different ways from a user or from another program and displays, or in the case of sound, plays output. The output of a program is usually based on inputs or the initial way the program was set up. For example, you could program an app to play a song as soon as it runs. So with Starting at level 9, and this is level 9 through 13 on code.org, I want you to take another look at the sample apps you explored before navigating to the app investigation starting at level 6. Consider what the inputs and outputs for the apps were and write these down in your journal. At the end of this lesson, you're going to submit a picture of the notes that you took at the end of this lesson, you're going to submit a picture of your journal showing the notes that you took during this lesson. So pause the video here so that you can investigate levels 9 through 13, whichever apps you chose before. Okay, go ahead and go back to those and create a list for the inputs and the outputs. For our wrap up, apps have unique purposes that appeal to different types of users. Apps take in input from users and output information in various ways. Users interact with apps through the user interface. Focus on an app from this level and explain its purpose. Okay? Give an example of who a potential user of such an app might be. Okay? This is an example of a create performance task writing practice. So this is the question. Focus on an app from this level. Read the question carefully, okay? Circle keywords or ideas that describe what you must write about. An app, explain its purpose, and potential user. Craft a response that addresses all of your important keywords, okay? And then reflect on your experience. Pause the video here so that you have time to do that. And then I want you to add these 3 vocab words to your vocab catcher, okay? You can pause the video here so that way you have all of the definitions and everything that you need to add them to your journal. Then what I want you to do after you get done with that is go back to code.org and complete level 14 for the check for understanding. If you have any questions, please send me an email.